those boxes that are within a radius of 100 units from the world origin, we could say select for all in objects where the length of the object's position is less than 100 units, collect the object. The function length returns the length of the vector starting at the world origin and pointing at the pivot point of the object. Since in the case of a box the pivot point is at the bottom, it might be a bad idea to use the center. The center property returns the geometric center of the bounding box of the object, regardless of the pivot point position. We could express the same using the distance function, which expects two arguments, both 0.3 values. In this case, we pass a second argument, the world origin position 0, 0, 0, and the result of this code is the same. Obviously, replacing the second argument with any arbitrary point in space, we can select objects that are within 100 units from that point. For example, let's take some random point and select all the boxes that are close to it. Now let's change the sign, mirror along Y. Obviously, we can also use the position of another object, for example, the position of a selected object, instead of a custom 0.3 value. We can use selection, the first object from the selection, and its position or center. And the result is a selection of all the boxes that are within 100 units from the selected object. We can select the corner and get all the neighbors, or select some object deep inside and get all its neighbors, and so on. We could, of course, introduce our own helper object to select other objects. For example, let's create a new object of class sphere gizmo, which is an atmospheric helper used for volumetric effects, but it has a radius property which is visible in the viewport and would be very useful in order to select objects. We can switch the user interface to help us selection filter, so we cannot pick any of the boxes and only our gizmo. Now we can change the code to measure the distance from the center of each object to the position of our gizmo, which is the object, and compare to its radius. Currently the radius of our gizmo is 100 units. That means that all the boxes within that gizmo are going to be selected. Now we can grab our gizmo, move it somewhere, change the radius, evaluate again, and all the boxes within that radius are going to be selected. Let's make it smaller, move it to a new position, execute again. Now we have a custom selection gizmo which we can place anywhere and select objects within. We can also access the scaling values of the scene nodes. This could be very useful, especially when analyzing scenes sent to us by other users that might contain non-uniformly or negatively scaled objects. Such objects could cause severe problems, for example when performing Boolean operations, animating, and so on. When using the mirror tool, the scale values of the mirrored nodes will contain negative values. Let's select the objects and use the mirror tool to create clones at 100 units distance. Now let's take a look at the scaling values of the original nodes and the clones. While the scale of the original node has a value of 1, 1, 1, the scale of the clone node has a value of -1, -1, -1. Such cases should be avoided. In order to detect such scaling, we can apply the following script. Select for all in objects where the scale of the object is not equal to 1, 1, 1, collect the object. At this point, all the invalid objects have been selected and could be repaired. For example, by going to the Utilities tab, selecting the Reset Xform utility, applying, and then using a normal modifier to flip the normals. At this point, looking at the scale of the selected node returns the correct value of 1, 1, 1.